Hello students, the question says in the given circuit, a circuit is given to us and he named capacitance of various points. So he has given C1 one value, C2 0.2, C3 2, C4 4, C5 and C6 and so on. We need the charge stored in C4 capacitor. We need to find what is the charge stored. As I told you, like we can solve this problem actually in 2 to 3 methods. First method, that is the method that I like the most, is method 1. It is called as voltage method. Let us see what do we do in voltage method. In voltage method, we will first convert everything into series parallel situation. As you can see here, this 2 microfarad, 4 microfarad, 2 microfarad, these three are in series. So we will write C series. We need to find that C series. So 1 by C series equals to 1 by 2 plus 1 by 2 plus 1 by 4. And remember, while solving the problems of capacitance, we never write this micro term. After solving everything, then we will write. Imagine writing micro every time. It will be like it will waste your time while solving the problem. So let us solve this. Half will become 1 plus 1 by 4, and 1 plus 1 by 4 is 5 by 4. And another important thing is, don't try to solve all three in a single go. If you are very good with maths, it's fine, but or else don't try to solve all three. Like, don't try to find LCM of these three. First solve two terms, then solve the next one. Okay, so from this we'll get C series equals to 4 by 5. 4 by 5 means like 0.8 microfarad. So this is 1 by C series, and C series would be ulta of this, that is 4 by 5. Once we got this, let me redraw this diagram in the next page. So in the next page, so this diagram, I can actually redraw it as, we have 10, we have 2, here we have 0.2, here we have 2, and from this entire thing will actually become 0.8. Now, these two are in parallel. These two, 0.2 and 0.8 are in parallel. 0.8 and 0.2, since they are in parallel, so C parallel would become 1 microfarad. Now again, we can redraw this entire diagram. So let me do it in the next page. So if we take this, so in place of this, I can erase this fellow. I can write 1 microfarad. Okay. Now let me hold here. I told I will solve this problem as though I'm solving in voltage method. That means I'll solve everything in terms of voltages. So 2, 1, 2, we can write that these three are sharing this 10 volts. Since these three are sharing this 10 volts, so we can write, let me call this V1, V2 and V3. So V1 is to V2 is to V3 equals to 1 by 2 is to 1 by 1 is to 1 by 2. Remember, in capacitance, when they are in series, Q is constant. If Q is constant, we can say V is inversely proportional to C, because the base formula is Q equal to CV. So based on this logic, I can write it would be 1 is to 2 is to 1. So this is how the charge distribution occurs here. Inversely proportional. So 1 is to 2 is to 1. Once we know it as 1 is to 2 is to 1, so this fellow would take two parts. So let us find what's the value of V2. So V2 value would be simply 2 by 4. This is sum ratio method. You will write what is the corresponding ratio of V2. The corresponding ratio is 2 divided by, add all these, 1 plus 2 plus 1 into the total voltage is 10. So it would be 10 by 2, which is equals to 5 volts. Now this V2 is taking 5 volts. Once we know this fellow takes 5 volts, we again go in reverse direction. What do you mean by reverse direction? If this fellow is 5 volts, if I take the previous figure, this one is made up of 0.2 and 0.1. That means you can imagine this fellow is 5 volts, this fellow is also 5 volts. Okay, because these two are in parallel. So if one has 5 volts, the parallel things also will have same 5 volts. Again, we will go in reverse direction. So from this, we'll go with the most basic diagram. So this is the basic diagram. If we go for this basic diagram, these three, this 2, 4, and 2 has to share this 5 volts. Because as you can see, this 0.8 indirectly represents these three fellows only. So this 0, since they are consuming 5 volts, these three together must consume the same 5 volts. Again, same logic. Let me again call it as V1, some V3, V4, V5. So we can write V3 is to V4 is to V5 equals to 1 by 2 is to 1 by 4 is to 1 by 2. So again we can write 2 is to 1 is to 2. So based on that logic, this fellow, but we can clearly see we need to eat 5 volts and they have to distribute in 2, 1, 2. So based on this, we can say directly V4 equal to 1 by 5 into 5. So we get the V4 as 1 volt. Now finally we got V4 as 1 volt. So we can say that this fellow is consuming 1 volt. Now what's the question first? The question is all about find the charge in the C4 capacitor. Since we know this is 1 volt, we can say charge equals to C into V. So C is 4 microfarad and V is 1. So it would be 1 volt. We'll get 4 microcoulomb. So that's the answer for this question. So the charge will be 4 microcoulomb. But this is not the end of it. This is only one way to solve the problem. I told you I'll teach you another way to solve the same problem. Let us see it. Let me tell you, it is better if you know both the methods. You should always try to understand both the methods. What is that method? Let us solve this quickly. We will use a normal charge distribution to solve this problem. We'll find this is called method 2, where we find C effective and then solve this problem. So we already did it. This entire thing would become, so C, these three, 2 microfarad, 4 microfarad, and another 2 microfarad. We know that it will become 0.8. 0.8 and 0.2 would become 1. And let us find what would be the charge distribution here. So once we know, this would be 10 volt. And this is this is 2 microfarad, and this entire thing would become again 2 microfarad, and this thing will become 1 microfarad. Let us try to find what's the charge that is flowing in the circuit. Let us assume Q is the charge flowing. We need to find the C effective of these three. So 1 by 2 plus 1 by 2 plus 1 by 1 equal to 1 by C effective. So again you will get 1 by C effective equals to 2 would become 1 again. So 1 plus 1 by 1. So it would be 2. So C effective is 0.5. Once you get C effective of this entire thing as 0.5, let us find what is Q equal to. Q equal to CV. So 0.5 into 10. So you'll get 5 microcoulomb. So we finally understood that 5 microcoulomb charge would be flowing in this circuit. So once we know that the charge flowing in the circuit is 5 microcoulomb. So let us see here. 5 microcoulomb will start, 5 will go here, 5 will go here. Now 5 has two paths to travel. This is one path and this is another path. Now 5 will divide it into two parts. Here, let us say Q1 is traveling. Here, let us say Q2 is traveling. We have to find Q2. You no need to do that. There is a direct way. Since these two are in parallel, we can see this 0.2 microfarad, this entire thing is in parallel. Since these are in parallel, we can say Q1 by Q2 equal to C1 by C2. That means it is directly proportional. We know in parallel connections, what would be same? Parallel, V is same. Since V is same, we can say Q is proportional to C. So based on that, like let us say Q1 would be Q1 by Q2 would be what is corresponding value of capacitance for this 0.2. Q2 means you have to take this entire capacitance. We already calculated it. It is 0.8. So it would be 1 by 4. So from this Q2 would be 4 by 1 plus 4 into what is the total charge flowing in the circuit? 5. So the answer for this would be 4 microcoulomb. So finally Q2 would be 4 microcoulomb. Even if you solve in this way also, you will still get the answer as 4 microcoulomb. This is called a charge way to solve this problem. To explain you, it took me so much time, or else I would have, if you practically while solving it in the examination, nobody does step by step. Clearly we'll say this 2 and 2 would become 1, 1 and 4 would become 0.8, 0.8 and 0.2 would become 1. So 1, 2, 2. So they have to distribute the voltage in a reverse way. Since they have to distribute the voltage in reverse way, so it would be 2 by 5 into 10. 2 by 5 into 10 and 2 by 4 into 10, and we get this value will be 5 volts, this will be 2.5, this will be 2.5. So this 5 volts should be distributed across them. With enough practice, you can solve these problems without pen and paper also. So try to do that, but if not, we have these standard methods to solve this. There is one more method actually